All right, so 3.1 quadratic functions. So whenever you graph your quadratic equation, it's going to give you a parabola. If it opens up in the shape of a U, it's considered concave up. With your vertex being on the bottom, that will be your smallest value, which is your minimum. If it opened down, upside down U, that's considered concave down, making your vertex the largest value, and that would be your maximum. Vertex, the coordinates of your vertex will be labeled HK, just like our center. A center of a circle, like we mentioned last section that we actually covered, which was 2.8. Talked about the center of a circle and the coordinates were HK. So the vertex, they consider the coordinates of the vertex HK as well. All right, so here we have the standard form of a quadratic equation. Let's see, can I scroll up? Everybody good? All right, so let me erase this and write this a little better. All right, so we're looking at the standard form of a quadratic equation. F of x equal to a times x minus h squared plus k. And this is the case when a is not equal to 0. So now if a is greater than 0, in other words, if a is positive, a is right here. If a is positive, then the parabola is concave up. That means it opens up. If a is negative, in other words, less than 0, the parabola is concave down, it opens downward. All right, graphing quadratic functions with equation in standard form. So we want to determine concavity. We can determine our vertex. Find your X-Intercepts, if any. Find the Y-Intercept. I should put an S right here. So find your X-Intercepts, if any, then find your Y-Intercept. And then you can plot the points from 2 through 4 and any additional points if necessary or as necessary. So you're talking about these points right here, 2 through 4, vertex, X-Intercepts, Y-Intercept. And if you need more points to help you with your shaping, then do so. All right. Let me know if I can't scroll up. All right, so so it says graph f of x is equal to -2 times x minus 3 squared plus 8. So first thing we can determine is our concavity. If a is positive, then it opens up. But we see here that a is negative. We have -2, so it opens down. Our vertex is going to be 3, 8. And if you go back to the formula, right here, you have -h and k. So you use the opposite sign. I thought I wrote that somewhere. Yeah. So we have hk right here. So if it's negative here, we use an opposite sign of k. I mean, opposite side of h, and using the exact sign of k. All right. So we use the opposite sign of h that's in the quadratic equation and the actual sign of k. All right, so going back here, so that's what we did here. We had -3, so we used +3, and then 8 was positive, so we used the positive. All right, questions on 1 and 2.
So how do we know when it opens down?
If a, the number sit right here, is negative.
Okay.
If it's positive, then it opens up. All right. So step 3, we want to find our x-intercepts if there are any. So the first thing you would do is recognize that all x-intercepts have y as 0. So wherever I see y, I'll go ahead and plug in 0. But in this case, we had f of x. And remember, f of x and y are the same thing, so we put 0 where we see f of x. And that's what we did here. So that's why we have 0 right here, because f of x is equal to 0. Now solving for x, the first thing I did is subtract 8 from both sides. So let me erase some of this so we can walk through it. All right, so the first thing we're going to do is subtract 8 from both sides. So 8 will cancel, and that leaves us with this. -8 is equal to -2 times x minus 3 squared. Then divide by -2. -2's cancel, and that leaves you with 4 equal to x minus 3 squared. All right, so now I need to get the square off of that quantity. So I'll take the square root of both sides. I might go blue. So that square root will cancel on the right. But then on the left, because I squared both sides, took the square root of both sides, then plus or minus. Do it like this. So the square root property. Whenever you take the square root of both sides, you have to use that plus or minus. Plus or minus square root of 4 is going to be plus or minus 2. add 3 to both sides. So these 3's can cancel on the right. And now I have 3 plus or minus 2. And since you can add 3 and 2 together, you do 3 plus 2 and 3 minus 2. So it'll be 5 and 1 as our 2 X-intercepts. And don't forget, when we first plugged in or defined these X-intercepts, we let y be equal to 0. So that's why we have these coordinates of 5, 0, and 1, 0. All right. Questions before we look at finding the Y-intercept? So to find your X-intercept, you let y be equal to 0. Now to find your Y-intercept, you let x be equal to 0. So that's what we did here. Took that same function, plug in 0 for x. So 0 for x right here. So inside of the parentheses, 0 minus 3 is just negative 3. Negative 3 squared is 9. Negative 2 times 9 is negative 18. And negative 18 plus 8 is negative 10. And so the coordinate of that would be 0, negative 10, because remember x was equal to 0 for the y-intercept. All right. Any questions? So now graphing those points. That's what I did right here. So down here, 0, negative 10. Here's 5, 0. And over here is 1, 0. And that's a rough sketch of my parabola. All right, questions on that? Any questions?
So I think I just got lost somewhere. How did we get the vertex again?
It goes back to, where are we? Right here. They gave us the actual equation in this form. So this right here is h, and this is k.
Okay.
Yeah. And so we use the opposite sign of h. That's why we have positive 3. And then for k, whatever sign this is, you just use that one. So that's why we have positive 3 and positive 8 for our coordinates.
Okay, thank you.
Not a problem. All right, questions before we go to the next one? We should be good. All right. So here, vertex of a parabola whose equation is f of x equal to ax squared plus bx plus c. So now our equation is in this form. and not in the standard form. And I'm just going back just to reemphasize. Last time our equations were given this way. This time our equation is given this way. So to find the parabola, what you would do is use this to find, well, not to find the parabola, but to find our vertex. Use this relationship, negative b over 2a, and then take that negative b over 2a, whatever you simplify that to be, and plug it into your function to figure out what k is. All right, so we see that a is -1, b is -2. We don't need c in this case, but c would be equal to that +1 over there at the end. But one thing we can establish that we know that this will open down once again because a is -1. Remember, if a is negative, it opens down. If a is positive, it opens up. And so to find h, that's negative b over 2a. Make sure you don't lose a negative in your substitution. So that's why I have those purple arrows there. There's a negative from the formula, and we're plugging in -2 right there. So that's -2 over 2 times -1. Once again, we're just following this right here to find h. That ends up simplifying to be -1. Then you take -1, what we found to be h, and plug it in to this function. So that's why we have -1 squared minus 2 times -1 plus 1. -1 squared is +1, so that's -1 plus 2 plus 1, which will give us 2. So the vertex is -1, 2. See, all they asked for was a vertex. Oh, it just says graph. It says graph. Okay. All right, give you a chance to copy that. All right, so you can go ahead and find the X-Intercept. Remember, that was the next move. You want to find the X-Intercept, you let y be equal to 0. Now this, if we could factor this, then we could do so, but if it's not factorable, remember you always can use the quadratic formula. And that's what I decided to do here. A is -1, B is -2, and C is +1. Plug those in accordingly. So that's 2 plus or minus square root of 4 plus 4, which is the square root of 8. After you do all your simplification. So that's 2 plus or minus square root of 8 over -2. And then got the decimal values for that. So those are our X-intercepts. I just went ahead and converted those to decimals just because we want to be able to graph it. So here, finding your Y-intercept, let x be equal to 0. So plug in 0 for x into the function. 0 squared minus 2 times 0 plus 1. So it ends up simplifying to 1. Somebody starting the alarm. Hold on. All right, so we have our Y-intercept now. And if we were to go ahead and graph those points, that's what our parabola should look like. All right, questions before I scroll up. Make sure we're okay. All right, a few key points about A. If A is greater than 0, then F has a minimum at x equal to negative 4 over 2A. If A is less than 0, that means F has a maximum at x equal to negative B over 2A. So we kind of mentioned that already, but just saying it in a different way. Because if A is greater than 0 is positive, it means it opens up, concave up. So that means it has a minimum at your vertex. But if it opens down, then you have a maximum at the vertex. Roll up. Okay. So the next one, consider f of x being equal to negative 3x squared plus 6x minus 13. Determine whether it has a minimum or a maximum value. Let's see, does it ask me anything? Oh, find it. Okay. So it says a equal to negative 3. You know, that's our a. So that means it opens down. Remember going back to what we said here. If a is less than 0, in other words, if a is negative, that means we're going to have a maximum because it opens down. So that's what we found out here. A is equal to negative 3. Opens down, so it means we have a maximum, not a minimum. Find the minimum or maximum. In other words, find the vertex. That's basically all it's saying, find the vertex. So we use the format that we just finished using, in which h, the x component, is negative b over 2a. So plug in 6 for b, -3 for 2. I mean, -3 for 8, excuse me. So that's -6 over 2 times -3. Right, that'd be a little better. And it's -6 over -6, which is +1. So x component of our vertex will be 1. Take that 1, plug it into the function. -3 times 1 squared plus 6 times 1 minus 13. That simplifies to -10. And that coordinate would be 1, -2. -10, excuse me.
So just so I'm understanding this, the vertex, or well, we have a maximum because it's pointing down, right?
Right. But if it was opened upward, then it would, that same vertex would be our minimum. All right. So you got C down here. Identify the domain and range. So when it comes to the domain and range of your vertex, I mean not your vertex, of your parabola or quadratic function, for your domain, it will always be -infinity to infinity. So if you're reading your x, you're talking about going from left to right, it will always continue to get wider and wider as it goes outward from the vertex. That means that it's coming from -infinity. If we were writing from left to right, it's coming from -infinity to +infinity. There's no value you can plug into your quadratic equation for x that will make it undefined. So for your quadratic equations, for your parabola, the domain, your x values will always be -infinity to +infinity. That's of course if they do something funky with it, but just general quadratic equations, -infinity to +infinity. Excuse me. Then your range. Notice in this case, now your vertex is going to dictate what your range will be. You're talking about going up and down, your y values. So here, the highest value is -10 for y. We're talking about y. So it would go from -infinity up to that -10. And you use a bracket because you can use that value. Now let's say if it was 1 -10 like this, that means your range would go from -10 to +infinity. You always use your lowest value first. So in this case, the actual example that we have, we would go from -infinity up to -10 because -10 is our maximum. That's our highest value. But if it opened concave up, then we would be looking at -10 being the lowest value, and it would go up to +infinity. All right. Questions on that? All right, questions? Any questions? All right. So let's see. That's it for 3-1. So next section we'll get into is 3-3. If we have time, we'll double back to 3-2, but I know I want to go to 3-3. Let me check out something real quick. While I'm checking this out, any questions? Everybody good? Come on. All right, so, okay, so we'll pause right here, give everybody a chance to get in there. So make sure we're taking advantage of the fact, that we're gonna, like I said, pause right here and not go too deep into chapter 3. But most definitely you guys want, you want to work on getting completely caught up so we can move forward and not have any type of hangups. So with that being said, any questions before we go into the weekend? Everybody good? Everybody straight? All right. So you guys have a great week. Be safe. And I will see you on Monday. Let me know if you have any questions. Feel free to email me.
Thank you.
All right. Thank you. You have a good one.